A ball thrown in the air has a height given by h equals negative 16t squared plus 64t plus 4. We're asked to find the following information. Part A, the max height. The maximum occurs at the vertex. But to find the vertex, we've got to get the axis of symmetry. Now, the formula on your sheet for axis of symmetry is x equals negative b over 2a. However, in our equation, our function, we have t as the independent variable, not x. So we're going to use t equals negative b over 2a. Next up, to identify a, b, and c, a is the coefficient of the squared term, which is negative 16. b is the coefficient of the linear term, which is positive 64. And c is the constant term, which is 4. Let's plug the b and the a into the formula we've got so far for the axis. This is t equals negative b, so negative 64, over 2 times a, which is negative 16. So we've got negative 64 over negative 32. So this happens when t is 2. Now we're asked to find the maximum height. What we found is not the height, it's how long it takes to reach that height. So to get our height formula, to get our height number, we're going to take the t that we just found and plug it into the formula we've got for height. So this is negative 16 times our t squared plus 64 times our t plus 4. Now if we evaluate this, we get that the height is 68. B, how long does the ball remain in the air? Well, the ball remains in the air until it hits the ground. If it hits the ground, this means that its height is 0. So that means we're going to take the original formula that we had and we're going to replace h with 0. So 0 equals negative 16t squared plus 64t plus 4. Well, let's go and plug this right into the quadratic formula. So we've got t equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now we're going to plug in the values for a, b, and c that we'd identified at the beginning of the problem. So this is negative b, so negative 64, plus or minus the square root of b, so 64, squared, minus 4 times a, which is negative 16, times c, which is 4. And this is all divided by 2a, which is 2 times negative 16. So let's simplify what's inside the radical first. So this is going to give us t equals negative 64 plus or minus the square root. Let's take 64 squared minus 4 times negative 16 times 4. And we get that this is the square root of 4352. And this is all divided by negative 32. Now we could go through and break the radical down, but in this physical problem we probably want to get a human readable number for time. So let's just go and plug this in a calculator directly, and we're going to get 2 separate time values. The first one, if we choose the negative sign, so our first time value is negative 64 minus radical 4352 over negative 32. And if we evaluate this, so negative 64, subtract the square root of 4352 divided by negative 32, we get that this time value is approximately 4.06. If we look at the other time value, we're going to choose the positive instead of the negative. So we get negative 64 plus radical 4352 over negative 32. So if we evaluate this, we get that this time value is negative. Now, a negative time value isn't physically meaningful, so we're going to reject this. So we know that it hits the ground, it stays in the air for about 4.06 seconds. The third question is, at what time does the height reach 50 feet? So I'm going to copy down the original formula. This was h equals negative 16t squared plus 64t plus 4. We want to know when the height equals 50. So we're just going to replace h with 50. So we've got 50 equals negative 16t squared plus 64t plus 4. Now to get things started, let's subtract the 50 over. So this is equal to 0. So this way on the left-hand side, we're left with 0. And on the right, we've got negative 16t squared plus 64t minus 46. And now we can plug this into the quadratic formula. So we've got t equals negative b plus or minus the square root of b squared minus 4ac. And this is all divided by 2a. Now we have a different c in this situation because of this 50, when we subtracted that over, we've got slightly different numbers this time. So a is negative 16 still, that's the coefficient of t squared. B is still positive 64. However, c is now negative 46. Let's plug these into our formula for t. So we've got negative b, negative 64, plus or minus the square root of b squared, so 64 squared, minus 4 times a times c. And this is all divided by 2 times a, and our a value is negative 16. Like we've done before, let's simplify the stuff that's inside the radical next. So 64 plus or minus the square root. We've got 64 squared minus 4 times negative 16 times negative 46. I plug this in my calculator and I get that this is 1152. And this is all divided by negative 32. So just like we did before, we have two separate time values. The first one, we're going to choose the minus sign. So negative 64 minus radical 1152 over negative 32. And for our other time value, we'll choose the plus. Negative 64 plus radical 1152 over negative 32. Now, if you decided to use the plus first and the minus for the second time value, it doesn't matter, as long as you have them both. So I'm going to evaluate each one of these on my calculator. Negative 64 minus the square root of 1152 divided by negative 32. And we get that our first time value is about 3.06. If we plug the other one in, we get that the second time value is about 0.94. The question also asks, why do we have two solutions for this when we didn't have two solutions for the previous problem? If you look at a graph, this might give some idea. The ball is thrown from 4 feet high. It heads upward and crosses the 50-foot threshold, continues on, and then on its way down crosses it a second time. That is why we have two solutions for this problem.